Hello, everyone. Welcome to our talk. I'm Alejandra Stamato, lead Android engineer at HubSpot.
And I'm Mauro Frezza, senior software engineer at HubSpot.
We're here to talk about effective app monitoring in production. And because we're going to be referencing HubSpot app a lot, it's good to understand what the app actually does. So the HubSpot we have, essentially it's a product that is a web app, right? And it looks like this, it's on the web, and it has a multitude of features. It's essentially a product that allows you, if you have your business, to model your business and store your contacts, companies, deals, tickets, etc. Very, very complex app, and the app, or the Android app and iOS that we're working on looks like this, and it has a subset of those features, but it's also huge. For example, you can see a list of contacts, and then you can, go and check your deals board, your deal dashboard, check the tasks associated with those deals to see which ones are urgent, which ones you have completed or not. Then create notes and emails, and there is a bunch of tasks and social integrations and marketing tools, etc. It's huge. So very, very complex app. So a multitude of things can go wrong. So imagine that, we're working on a deals dashboard, and we are adding a bunch of features in production and a lot of improvements to our app, and then we'll finish working on that. We're ready to put it in production and ship it. We ship it, and that's it. And then as developers, we're ready to work on the next thing, right? But as we're working on the next thing, and we already have forgotten about the things that we just shipped, right? The reality is that anything could be happening in production, and the user could be having a very different experience than what we had tested in QA. So one good day, we get a Play Store review saying that the app is slow, right? And it's a one-off maybe, so we don't need to kind of jump onto the problem. Maybe the user is testing, maybe they had one problem, or they're testing on a low-end device. It's not that critical to jump straight away. But then we got another review saying the same thing, and then another one, and then another one. And it's just not great. So now a couple of questions that we can ask. How bad is the feature performing? What's happening? And more, and in comparison, how was it performing before? And most importantly of them all, how do we even begin to understand the problem and know what's wrong? So in this talk, we're gonna talk about strategies to introduce or enhance observability, define the metrics that would allow you to measure your most important features and see how they are performing in production, monitoring them so you see if things are going good or not, and then iterating on this monitoring process, because as we'll see, this process never ends. Just a disclaimer, there is multitude of solutions for this, some more automatic than others. This is just a solution that is working for us so far. There is no silver bullet to the problem of introducing observability and monitoring. You're not gonna leave this talk with the 3 lines of code that you have to add to your app, so this works magically. And you will see why in a second. So just a bit of a disclaimer before we introduce observability.
Right, so we mentioned the term observability, so I think it's useful to define what it is. And you should think of observability as a characteristic of a system, in this case, your application, to allow to be observing internal states and how it communicates, the internal part communicates. So you want to have an application that allows you to see the internals in certain ways using monitoring tools. But why would you do that? Well, the reason is because you want to improve the reliability and the performances of the app so you can provide a better user experience. In order to do that, the system needs to be observable, so you need to be able to see how reliable it is in production when users are using it. But introducing observability itself is a very complex task. So when you're approaching this task, you should approach it in a strategic way and think of all the different implications it has. So you should think of it as it needs to be effective. So you need to be able, once it's out there, you need to be able to debug the root causes of the issues, and you need to find what are the problems. You need to be able to see them and then to find them. It needs to be able to be efficient. So once you have your monitoring in place in your app, it doesn't have to take an overhead in terms of CPU, memory, or data network. Otherwise, you're really defeating the whole purpose of what you're trying to do. And it needs to be scalable in the sense that it needs to allow you to support the additional functionalities you'll add in your code base and additional team members that will be in your code base. And all these, you can see them as your goals for your observability strategy. So for us, the strategy can be defined in 3 steps. The define, which is where you try to come up with all the information you want to know about the application when it's out there, so you can understand how reliable it is and how performant it is. The collect part is where you add the instrumentation, the monitoring inside the application. So you want to understand where in the code base do you track this information and what kind of information do you need to track in your code base. And then there's the last part, which is more about the process, which is you need to monitor the data that you collect. So you can have tons of data, but if you don't monitor it, it's useless. And so there you need to start reading it, understanding, and then iterate over it, meaning fixing if the tracking is not correct, or act on the issues that you find and trying to improve your process so it gets easier and easier to monitor this issue and fix them, and maybe not even have them reach production. So the first step is building knowledge. And the knowledge around the app must be reliable. So you need to be able that once it's out there, the data that come up that you're tracking, you need to trust that it really represents if there is a problem in the app. So you need to be able to track all the information. And once they are there, you see, okay, this actually is telling me there is an issue in production. It needs to be comprehensible, so you can have tons of data, but if nobody can make sense of it, you basically have nothing. So that needs to be simple enough that basically everybody in your team can approach and can understand it to some extent. And it needs to be shared, so it's not one-person effort, so there shouldn't be just one person that knows everything about monitoring and the rest of people just are ignorant of what is going on, but it needs to be something that every single developer in the team can look into it and can understand and can act upon it. And all this builds an understanding of the app in production, of how the user experience is out there.
Okay, so we're talking about building knowledge, so let's start understanding how to build that knowledge and how we do it at HubSpot. So let's start thinking about what the users can do in your app, and remember, like for example, in our deals dashboard, you look at you essentially take a look and you think which buttons can the user click, or what is the user journey that you want to track, right? And this screen in particular is very complex for us, and it has a multitude of things that the user can do. So the define step to collect that knowledge can be divided into these 3 steps that we're gonna make a little bit more intentional coming forward in the talk. But the first thing that you need to think is this, right? The feature to monitor, what the user can do. In this case, loading the list of deals, pulling to refresh, creating a new deal, saving operation, all these things like macro features that you want to track. And then for all of these features, maybe there are some of them that are more complex than others, so you may want to understand a little bit more on them, and then you dig deeper into the internal aspects of how you're getting that information that you need. For example, maybe fetching your data has complex domain logic, complex mapping or parsing, or a repository call that you really want to understand which parameter you're sending or what could go wrong. And finally, you can build indicators with a combination of all the things that you already collected that will give you an indication of the availability of the screen, like how much you can access that screen in normal circumstances, the latency, how slow it is, or the crash rate, how stable that screen is. So an example of that, we go back to the deals dashboard. A multitude of things can go wrong here, very, very complex screen. At the top, we have a sales, we have a pipeline picker that will reconfigure the context of the whole screen, right? And then we have a tabbed navigation view that is just like a collection applied to the rest of the screen as a collection of filters that you send to the API. Quick filters on top of those filters, and then a horizontal view that it's like a Trello board that you can scroll and you change the deals from one stage to the next. So yeah. the first thing that you would like to know is when you try to load the screen is maybe the screen loads, but it loads a bit too slow. So the first indicator you want to track is the latency that you have. And then maybe the screen doesn't load at all, and that's a terrible user experience. So definitely you want to check that too, which is the availability indicator there.
Right, so we saw how we break down the screen in different parts, and we start from the product perspective, approaching reliability. And this is the way how we look at reliability in HubSpot. We can call it like a product-minded reliability. The reason why we do that is because if you think about it, product managers have a way to understand the pain points of customers, but developers don't have, for example, the same tools. So you don't, for example, do customer calls as a developer to with the customers, while product managers do. For us, what we can do to observe what are the pain points is to use the observability, so using monitoring in your application, so you can get a sense of where the user feel friction in your app. And so you can think as a developer and product manager having similar responsibilities, just different tools. You can think of, you need to understand the customer experience in the app, so when the people are using the app, and then you need to monitoring actively, and then think about it and develop any solution. So product manager come up with new features or improvement. We understand, okay, we need to fix this bug, or we need to make it more performant. And so you deliver product enhancement, and you improve the customer experience in doing this. So the advantage of doing this is if you use this approach, then you're able to communicate reliability more easily to the product. So you're able to go to your product managers and say, okay, reliability is a problem, is impacting the customer experience. You also start thinking of your application as a product that requires value. So it's not just something you write code, you push it, and it's out there, but you actually try to fully understand how people are using it and what's the experience in it. And more importantly, you're able to continue enhance the application, so add features, improve it, but doing it with confidence. So you know you're releasing things that actually work, and you're able to know if they work and otherwise roll back. One useful tool in all this are indicators that Ale mentioned, and we call them like the name is key performance indicators, and they're extremely useful if you want to communicate with the rest of your team and the rest of your company any problem related to reliability of your app. They are these are some examples of some of our KPIs, and you can see we have the record overview availability. So we define, okay, for us, that feature is very important, so we need to be sure that the availability and the latency on that feature is kept to 99%. And so we define very few KPIs related to product functionalities, and we keep monitoring them. One suggestion that we can give you is start with very few ones, very focused on the very important parts of the app, because it's very easy to build tons of KPIs, but then you need to monitor them, you need to understand them. And when you're approaching the effort of like trying to introduce this process, it's very overwhelming, so start with very few elements and go with that. They are extremely useful if you want to set some goals. So you want to say, okay, in 6 months, we want to reach 99% availability on a certain screen, or we want to reduce the latency. Or if you're exposing functionality to other team, or you're kind of working as a platform team, you can also define SLA. You can say, okay, our API is always going to have 99% availability, and we will strive to make it work. And if you use a top-down approach, so you start from the product and you try to break down all the aspects that you need to monitor, it becomes also easier to define a KPI because your starting point is the user experience. So if you already know what you want to measure and what you want to observe. So here we are now in the collect part. We're going to see how HubSpot does the collection of metrics in the code. So we're going to see more practically where in the code we're going to put stuff. We can break it down in the 3 layers of an application. So we got the UI, the domain, and the data. On the UI side, on HubSpot, we don't track anything in composable or in fragments. There's other tools for that. The reason is also because there's no information that we are interested in there, and also it can lead to tracking too much metrics. Imagine if you track something in a composable and it recomposes too many times that it's going to skew your metrics. So what we track is on the view model, and there we focus on user functionality, so we can think, okay, we are loading data. Is this loading data going to work? What exception do we get? How many times does it fail? How long does it take? And so we are more focused on the view model, trying to see, okay, the user functionalities and the reliability of it. Then once we have defined monitoring there, we're going to see, okay, if we detect there is an issue, the view model, we need to understand why. And so we move down on the layer, we go into the domain. If we have domain logic and it's complex, we're going to start tracking there. So we're going to start tracking availability and latency as well, but also any kind of exception that we don't expect to happen, but it could occur. Maybe the API can throw an exception, but we don't know exactly when. And so we want to monitor it and see how often and how impactful it is. And so we can debug where this wrong behavior comes from. And then if we go one layer lower, is like we go into the data. Here, usually we monitor endpoints, so we're gonna monitor errors and also latency of them, just to see, to have some data we can cross-match with the web, or if we have other API that are external, as we have some data, we can say, okay, this problem is due to a slow API, or this error comes from wrong data coming from the API. So now we're going to see more in details how we track the functionalities on the view model layer.
All right, let's start collecting some metrics. So we're going to be using this screen as an example, our list of contacts, right? So Mauro mentioned, let's start on the view model. So let's start on the view model. We imagine we're going to have something like contact list view model, extending for architecture components of Android view model. And it will receive in the constructor a class, maybe a contact list monitor class, just a simple class that will essentially have the responsibility of coordinating all these monitoring calls. We're going to be delegating a bunch of these tasks to the monitor. So we can imagine we're going to have a call, do load contact list in the init block of the view model to start our process of downloading everything that we need. So right before that, we can start calling monitor.trackScreenLoadStart to begin the process of collecting the metrics or indicating our task. This screen started loading. And then in actually the do-load contact list method, we're gonna, using the correct scopes, we're gonna call repository.getContactList from our repository and update the UI if everything goes well. And right after that, we're gonna call monitor.trackScreenLoadCompleted because it finished the loading of the screen successfully. This is if everything goes well. But if something doesn't go well, we can do a try catch because this is coroutines, and we have our structure concurrency, and then we catch the exception if there is an error, and then we call monitor.track failed screen, passing the correct exception. So we can do something more with the exception. And of course, updating the UI accordingly, maybe showing a snack bar, an alert dialog, something. And then because the view model has its own life cycle, what can happen is that the user abandons your screen before it actually finishes loading. And it will call the onClear method of the life cycle of the view model. Just in case, so you don't lose events, you can call something like monitor.trackAbandonScreen for all those tasks that didn't fail but didn't complete it. Our monitoring class, what we mentioned, it coordinates multiple what we call system tasks. And those system tasks can be everything that you can do in the screen. So it can start the system task 1, which is loading of the screen. It can start a system task 2 of publishing a file, downloading a file, or creating an event, creating an object of some kind, etc. So you have a collection of these system tasks representing what you can do on the screen at any given time. And we use them to track the latency and availability with convenient parameters to do so, as we're going to see. System tasks are just a plain class. that has basically three main parameters. One is the name, so you can query by it in your wherever it is that you're sending your metrics, so you can basically identify it and find the information. A module that it's very useful to group them together in a way that makes sense, and Mauro will talk a little bit more about how we organize all of this. And the type. And the type is interesting because we saw one example, screen load, like an example of system task of what we do when we load the screen. But you could be doing other types of tasks, and you need to differentiate them because when you're measuring latency, you would expect to have different thresholds. Obviously, a screen load needs to be faster than, for example, a task that represents downloading a file, in which you expect that to take longer. So this is very convenient to just like tell them apart. So screen load, you will have a threshold that is like less forgiving, and for a download, it would be separated from your latency KPI, basically. So there is that. That's why we use it for. And then we would have a state. And again, we saw an example of all of them. The system task can have a state started, completed, abandoned, or failed, depending on where it is. And it's important to track if you've started one, what happened with it afterwards, or else it could lead to funky results. You need to mark it as what happened with it. Completed, abandoned, or failed, or else it's lost in the ether and it generates monitoring problems. So yeah, we can imagine that we have a method in the monitor class, in the system task class, that is start receiving properties, anything extra you need to send to the monitoring system. And the most important things of this code is that you would track when it begins, so you can do these calculations of how much it took to finish. You would have start time and you will have an end time correspondingly. The state, at this point, it started because the method is called start. And then you will call report to logger. Now, report to logger is an abstract, and it could mean anything for you. And it could be, any system that needs to be tracking something, and it could be multiple systems, like a system to do funneling and tracking user usage. In our case, we're going to be talking about the system that you use for doing performance and monitoring, which is New Relic.
Right, so all this seems very straightforward. One team just pushes metrics to a database, in our case, New Relic. But once you have a complex application, and most Android applications nowadays are getting more complex and complex, so require more people, and you have different teams working the same code base, this becomes very hard because you have tons of people and tons of metrics pushed up, and you cannot make sense, and some of them you don't understand who owns which metrics. So Ale mentioned that system tasks have a system task module. This is our way to organize the space, the monitoring space, so that we can clearly understand which metrics belongs to which team. So each system task and each metric that we push up is organized into this module. So the organization is done either physically, so we organize all the code that is in one physical module belongs to is like logged in together, or we can think more from a domain perspective and putting together a bounded context of different modules, physical modules of code, and have them put all the metrics together so you can see the whole feature and the whole context in the same space. And this is what you can imagine our monitoring space to be. So we have different teams. We have CRM, sales, and marketing. But inside each team, there are different functionalities, and we group them different. So we have association, for example, records and data set in CRM. So we are able to pinpoint exactly what metrics belong to what functionality, and it becomes much easier to organize the whole space. The result is we are able to build dashboard that gives us a high-level overview of what are the areas of the app that are problematic. So this is you can see each module has an availability and a latency, and we can see, okay, for example, attachments in this case requires our attention because it's the availability is way below 99%. We also use like visual cues like colors to clearly see exactly where to find the problems. Then once you identify an area you want to focus on, we jump more into a specific dashboard that can go more into detail. So all our dashboard for each feature tend to have a similar structure, so it's also easier to navigate between one and the other. And in general, we show availability, latency, but then we go into each system task, and we want to see the availability specifically for system tasks. We want to see how many tasks are abandoned, because it could mean that there's something wrong or we don't see, and users just leave out of frustration. But then we obviously need more information once we identify there is an issue somewhere. So we track also exceptions. And so we can go and see in details if there's any specific exception that occur in that functionality that could explain why a system task has maybe reduced availability. And then as we said, we also monitor endpoints, and we can see trends over time. So we can see a time series of errors, and we usually monitor like HTTP 400 or HTTP 500 errors. But we use different ways to visualize the same data, because sometimes it's easy to miss an issue that has, for example, very low error count but occurs very often. So we want to see, okay, for each error, how often does it happen in a span of time? So I would suggest when you build dashboard, try to create different way of visualizing the same issues, because it helps to pinpoint the exact problems. All this helps building visibility into the monitoring space, so visibility into how the app is performing actually. KPIs, we said, great to define the user experience, but they're just a starting point. They're just like something that tells you, okay, you should focus on that aspect, or you should focus on another one. Endpoint reliability is another important aspect to monitor, but be aware that you should use them as a kind of a canary, something that tells you something may be wrong, and you should pay attention, but they also create a lot of noise. So be careful when you are monitoring them to not fully trust that like a spike in errors necessarily means there is an issue. It could just be a user that is trying 20 times the same operation that fails because maybe it doesn't have connection or it doesn't have anything else. And also errors and exceptions can be useful just to have this kind of a safety net of information that can help you understand if there is something that you're missing from other monitoring. So there are different ways that you should see the problems, and you need to find different ways to visualize your space.
Okay, now we're happy we've collected all of our metrics. And now let's take a look at them. And we're going to discuss now the monitoring process. So we come from here, and now we're all the way into the third step of our strategy to improve observability. And so sure, now we've collected all of our things, and we have observability into the system, and we open our dashboard, and it looks like this. And there is a bunch of numbers and colors and numbers, and if you have built the knowledge of what all of this means, then probably you understand already what needs your attention and how. But if you're a new joiner to the team, this could be like a little bit intimidating. So obviously, another key important part of the monitoring process is learn about what you see by virtue of doing this, of looking at this dashboard multiple times. And then sharing the responsibility of monitoring, because this should be a responsibility that everyone on your team should have. It shouldn't be like one person being the monitoring person, So having into consideration these three things is that we implemented at HubSpot the role of metrics DRI, or directly responsible individual. And it's a rotating role that changes, that rotates for every person on the team on a weekly basis. And it has several responsibilities. First off, check the metrics, right? Like every day during your week in which you are the responsible individual, opening the dashboard and check if everything is all right. For example, I open my dashboard and I see something like this. And then I check, is there something that doesn't make sense? And then flag what is suspicious. Oh, I'm going to take a closer look. This kind of looks weird, but does it look weird? Was this a thing is it still ongoing? Should I be taking a better look at this? And then you investigate if you consider that it's worth to take a look at that. And on the subject of investigation, we can tell you real examples of things that happened in our team thanks to this process that led to improvements in our code. We have 2 examples. And we are in the fix and improve part of the monitoring process, because obviously, by virtue of doing this again, the whole goal is that you are able to improve your code and your user experience. And we have a lot of examples. but we can just talk about two because these two were interesting. And the first one was of an untested condition in the configuration of certain users for the app. We were mentioning that HubSpot allows you to model your business with contacts, companies, deals, tickets, but maybe your business is very complex and it has an object, a type of object that you need to model particularly with your own rules and your own configurations, and it could be literally anything. It could be very complex, right? So for example, this user here in their portal, they have like pets, like the object pets, with whatever that means, right? Like whatever name and properties that they have. What we noticed is that the user tried to load the screen. It took very long time, so much so that they just like didn't wait for it to finish, and they would just like leaving the screen before, right? It's loading, loading, loading. It never finishes, and then, you know, whatever, goodbye. And we obviously didn't know that, but we noticed was this, like the ability SLA for that screen dropping massively with a big red numbers, like, please pay attention to this. I don't know if you're familiar with, well, probably you all are with SQLite or some query language. New Relic has its own New Relic query language. And it's like, you know, you can build these graphs with just like a query on a table, select from mobile system tasks, which is a table in which we're sending all of our events, where the module is these custom objects, and the task name is the list of custom objects, and the state is abandoned because the user was abandoning the screen before it's completed. And, you know, we took a look and investigated and traced the error back to the source and the configuration of this particular set of portals. And the error was textbook error, right? We were running an update to the database on the main thread, something that you don't want to do, that you cannot do. Because you get this, illegal state exception, cannot access the database on the main thread. And actually, it was a line of code to fix this, right? Like just using the correct dispatcher. But we didn't know because obviously we didn't have the particular set of conditions in our UNE tests that would check this or capture this and allow us to fix it. Now we do. We covered this with the proper testing. But this is what Mauro was referring to when he was saying that we were able to release with confidence. Even if you don't have your UI, even if you missed the condition, you don't have your unit test in place, if missed QA, it missed UI tests, it misses everything, you're still going to be able to know somehow if there is a problem before it escalates to your whole user base. And that's very, very powerful. And then the second case was we observed some latency on the dataset screen. Now, the reviews that we were showing at the beginning of the talk were fake for, you know, dramatic purposes, but the problem was real. Let's remember, this is the deals, the dashboard of deals. And what we were seeing was that we saw a dramatic increase of the system tasks connecting to loading the deals of dashboards. And it was very, very graphic, right? Again, it's a simple query where the task type is the screen load in the module dataset with task name board deals. And you get this graph over time, which is pretty cool, with just simple one keyword time series. And then New Relic is smart enough, and it gives you this beautiful graph, which is very visual. And we had another visualization of the error too. We saw a massive spike in the amount of users observing loading times for that screen for more than 2 seconds. Dramatic increases. So this is another way of visualizing the same information, as Mauro was saying as well. Very, very useful. So yeah, essentially we had a problem. We needed to check what was going on. We also did an investigation, but in this case, we were not as lucky, I guess, or as successful, as in no change we had done on the client side, on the Android app, was justifying these loading times. So we were able to pull in our backend team, and with this data and with these charts, communicating the need for them to help us out, see if some work could be done to increase these times based on changes that they have put up in production at that time. So we created an epic for improvements of the data, say, latency KPI, and they created, you know, a bunch of tasks of parallelizing this and maybe use another service that was faster. And that all those changes are already in production, and we saw decreases of these loading times. And we were able to generate all this change with data, very, very quickly communicate the problem. We were not just based on, you know, reviews are very flaky. You can take a look at those, but this was actual data. Like, this is
24, like whatever, 95% more slower than when it was in the release, in the previous release. Why? And that is awesome. And it's quicker than just not having this data with you. So yeah, that concludes the investigation. But as we just see, maybe sometimes it's not enough to solve the thing. We don't have all the information we need to solve it within the bounds of our team, and we have to loop other developers or other teams. And that can look as simple as, hey folks, I message on Slack, I am observing a dip in our latency KPI. You know, that will generate the conversation, and then you can jump on a call and figure out what's going on and the next steps that need to be done. It doesn't have to be anything complex. It's just like allowing the communication to happen and put up the channels that will allow you to do that. So there is that. And then finally, you drive a checkpoint meeting at some point in the week, either to do a handover or just to share or what are those observations that you've had for the week. Hey, I've observed this. Has anyone had this problem before? Or maybe you can debug a problem together during a span of time. And that way you learn from one another in the team how, it doesn't have to be a long meeting, how you would debug a certain problem and how you could trace from a certain indication of problem into the actual source.
Okay, so now we went very technical in all the aspects, but we just want to leave you with some tips and tricks that, that may work for you, so take it with a grain of salt. We are in the iterate phase, so in the phase where we are just trying to improve the process of monitoring the app. The first one is, once you start this monitoring constantly and having a periodic meeting to check the metrics, keep a diary of what's investigated, what the problem you notice, and what has been discussed, and any kind of action items that you want to create out of that. It could just really simply be a Google Doc where you just throw in all the notes of the meeting, all the links to tickets, or any kind of graph that you want to keep a track. And this is extremely useful because then it's you start building up a knowledge, especially at the beginning when there's a lot of gaps on how do you debug certain things or where do you look into that. So it's really helpful to have one single point. You build up a history of problems. So for us, many times it happened that we encounter an issue and we remember we saw it before, and so we were going through the doc and we find similar issue, and we already investigated maybe, and we said, okay, this is not an issue, go on, move on. And it helps you to demonstrate the impact. After a while, you will be able to see, okay, these are all the issues we encounter and all the issues we fixed, and you're able to show to the rest of the team, to the rest of the company, the impact of having such a process in place. Another useful thing is, once you have each team monitoring their own part, is having periodic reporting among the teams around the KPIs or around the most important metrics. The reason for that is you build up accountability so that each team is actually really looking after the metrics and acting upon them, because if you do a meeting maybe every month and then from month to month one team always have one KPI that is going bad, then it means they're not really acting on it, and so there's no real value of looking at the metrics if you don't act on it. It also drives the focus, so you're able to make the teams focus on what really matters for the products, and you're able to guide them over time on what they should start paying attention. And also, it's a great place to start sharing your know-how, so knowing how to debug and what you learn in your process, and maybe like refine the process across team. All this helps to build focus around reliability across teams. Okay, one of the last mention is about alerting. We could have an entire talk about alerting, but we're just going to give you some bits and pieces once you will start dipping your feet into that. The first one is try to think of the strategy you want when you want to introduce alerting. So you could have different way you approach the alerting. You could have maybe very heavy alerting on the back end, so that is so detailed enough that you don't really need to have it on the client. Or maybe on the client you can just have very high level alerting on some KPIs or on some exceptions. It's something that you need to consider yourself. You don't necessarily need to have tons of alerts on the client just because the backend does it, because then you also can create noise. Alerts are very disruptive if they are wrong. So if you have an alert that goes off every day, but it never represents an issue, people will ignore it. And that at that moment, you lost the trust of your team, you lost the trust on the alert. So when you start introducing alerts, make sure the noise is not too high, otherwise you really defeat the point of having an alert. Also, you should consider what you can do if the alert goes off. So if you detect there is an issue and it turns out that most of these issues are related to backend and you're a mobile developer, you cannot act on it, what's the point of having the alert on the client? Especially if then that alert always matches an alert on the backend, you should consider if you really need it, because if you can't really do anything, it might not be useful to go through the effort of putting alerting in place. And also, at the beginning, there will be false alerts because you're trying to understand how the metrics work and how the user behave. So there will be false alerts. Our recommendation is use those situations to try to understand why they're happening and why the metrics are showing this problem, and how you could refine the alert to make it less noisy. Okay, so now this is like we're almost over, so let's do just a small recap of all the things that we mentioned. You should think of monitoring in a strategic way. So our way is breaking down in 3 steps. So define where you try to build a knowledge of all the things that happens in your app, so what you want to track. And once you know that, you move to the part where I'm going to add the tracking into the applications, and there you will try to figure out which part of the code you need to modify to add the tracking to have that information so that you can build then those indicators that you need. And then after that, there is the most important part and the most complex part, because it's actually more of a social problem there to solve, is having people looking at the metrics and iterate over that, fixing the issues that occur and sharing the knowledge of how to look at that. But we can say that collecting metrics is just the beginning. So once you collect the metrics, it's not going to be enough, and it's not going to solve all your problems. So don't think just because you have observability and metrics in place, so yeah, all is good. No, it's just a tool that's going to help you build better, but you need to pay attention. And it's required team efforts. If you introduce monitoring, but then you're the only one that knows how to use it and nobody else either care or pays attention to that, then the point is defeated, because those metrics are just going to be pushed and nobody's going to look at them. And it requires continuous improvement. Once you have it in place, you keep refining the way how you track it and the way how you look at it, and you build up the process around it. But we can say that this really is helpful, and this is like a review of one of the customers that encountered one of the issues that Ale mentioned. So we can see that it really pays off to pay attention to these things, because the customer are going to reward you for that. Thank you very much, and if you have any question, please reach out to us after. I don't know if we have any time for Q&A. No. Thank you.